So let's talk domain and range here. Domain is the space that the graph takes up on the X. So when you look at this for domain and range, I picked these graphs very specifically because they had endpoints on. They don't go to infinity. Makes domain and stuff like that easier to see. The first spot on the X that we have graph is right here at -6. The last spot is 6. There'll be no more graph anywhere past +6 to the right. There's no more graph anywhere to the left of -6. In between those two spaces is everywhere where there's graph, everywhere where the graph exists. So the way that we would represent this is with interval notation, because that's exactly what it's used for. The domain, the X values that this graph are from -6 to +6. It's everywhere in between there. That's its address, that's its home. We're going to include the -6 because this dot is filled in. We're going to include the +6 with that squared ended bracket because that one is also filled in. You get what I'm saying? It's the stuff on the X where anywhere you look up or down, you're going to have graph, okay? The range is very much the same concept. But instead of looking at the X's, we look at the Y's. So you got to look for the lowest spot you have that your graph exists. The lowest spot for this graph is down here at -4. Where's the tallest spot? Up here at +3. And if you look through, if you're looking left and right as you go down, there's graph to either side of that everywhere. So this is the range of the graph. Range is always up and down. Its lowest point is -4. And its tallest point, 1, 2, 3, 4, 5. Now you see this dot filled in, so that makes that really easy. That's included, which is that square bracket in interval notation. Now the 5 can be a little bit challenging, but if there is graph there, that means the dot is filled in. Unless it's specifically drawn with like an open circle right there, then you're going to include that point. So that means that topmost point up here at Y is 5 is included, and this one will get a square bracket as well. All right, let's talk increasing, decreasing, because we're going to write the answers the same way with interval notation for these two graphs. So what does it mean for something to be increasing? Which way is it going to go? It's going to go up, right? How about decreasing? Decreasing is going to go down. So what we're looking for is increasing and decreasing is a description of what the Y value is doing. What makes this tough is when we list the answers, we list them for what X values that is happening, which can get confusing. So let's highlight this. The first part of this graph, increasing or decreasing? It's decreasing, and I'm going to zoom in so we can see it. So that first part of graph is decreasing. The Y values are going down. But when we list its answer, we list that by the X values that is happening, meaning it's decreasing from -6 to -4. Because the description for decreasing, increasing is what the Y is doing. But we need to know the address, the X, for where that stuff's happening. So when we list this part of the answer, that one was decreasing, we would use interval notation, and it's always going to get rounded for this. -6 to -4. That first part of the graph was going down. What's the second part doing? So let me put my highlight back in here. Let's do decreasing in green. The second part of the graph is increasing, right? Because the graph is, and you see it when we trace it, we always go left to right on the graph when we look at this. My pen had to go up to highlight that. So this is a increasing section. This one was a decreasing section. It starts here at -4 and goes to -2. Now with increasing and decreasing, we never include the points of change. So what I want you to think about, like you're jumping in the air. If you're standing on the ground, you jump in the air, what do you do first? Which way do you go? You go up, you increase, right? And then eventually gravity takes over, and what do? You go back down. But what happens right at that exact moment at the top of your jump? Because if you jump, you almost feel like you're floating for like half a second, right? That exact moment right there is when you stop increasing and you start decreasing, where you're not changing at all. So the moment in ours is where this is at -4. At that exact spot at -4, we're not decreasing anymore, but we're not increasing yet. We're changing direction. So that's why we exclude the endpoints in this. So this increasing is going to be -4 to -2, and they're both going to be rounded brackets when I go through and list them. My next section, I'm going downward, so that's a decrease. We end up down here at +2. So it's -2 to +2, and that's a decrease. And I'm going to list that right next to the other decrease. But remember, when I have two intervals that I want to join together, I put a little U next to them that says this one and that one. So it means it's decreasing from this interval and this interval. What is this next interval doing? Increasing or decreasing? Is it doing either? No, we move left to right. Do we go up or down in that stretch? Nope, that's our constant. Now I don't have a space for us to list constant. But it is good to list it for yourself as you go through the graph because there's no spot for that. And then the very last part, we're decreasing again. And that's from this 5 down here to that 6. So we're going to add that interval to our decreasing interval. So you can have multiple intervals listed for these answers for increasing and decreasing. Let's do the next one real fast. So we're going to do increasing, decreasing for this. Now the reason I'm doing domain and range and increasing, decreasing at the same time is because they use interval notation for their answers. So let's go through and highlight this and label it first. So the first part is decreasing. And then I'm going to put this dot right here where I know it stops decreasing. Second part was increasing. What color did I use? Used red. As my graph is going upward to this spot right here, and then it turns and we start heading down again. That one is decreasing. There's no constant in here. And let's put some dots where this thing ends. So this part was decrease, this part was increase, this part was decrease. So we'll have two intervals for decrease and one interval for increase. So it starts at -4 and goes to -1 is where the graph is traveling downward. So decreasing is -4 to -1. Second interval was -1 to 3, and that was an increase. And our last one was a decrease, right? From 3 to 6. And that's the end of that graph. It's done. Now, the only things that we haven't talked about yet, we haven't talked about our minimum maximums and our X and Y intercepts. Now, the reason I left these here for the end, these are going to be described answer-wise. These are coordinates. These are points. So these things in green that I'm highlighting, we're going to describe these answers as specific points. They're going to have X and Y coordinates. So anything I highlight in green, the answer is a point, meaning you're going to need to list an X and a Y. All the stuff in yellow that I highlighted, that's interval notation for those answers. And now that you see me right on the screen, you fully understand why I type a lot of these things on the slide. Now, it's really easy to get the two things confused because they look really similar. Okay, so that's why I wanted to make sure we denoted the differences between them. So let's talk X and Y intercept. Now, for these graphs, they're not perfect, but we're going to pretend that they're right there perfect because I don't want you guys splitting hairs over whether that's negative 4.2 or 4.4. So let's say we know what an x-intercept is. An x-intercept is where our graph intercepts or crosses the x-axis. So we're going to say here and here. And since these graphs were kind of old and they weren't perfect, we're going to pretend that those were perfect values. So this x-intercept is a point. The x value of that point is -4. To be an x-intercept, your y value has to be 0. Now notice that we have more than one x-intercept here. We cross the x-axis over here as well. That's +5. So we put that in the x part of that coordinate. And to be on the x-axis, be an x-intercept, we have to have a y of 0. Now our y-intercept is where we cross the y-axis. So this is a y-intercept. And these down here, these are x-intercepts here and here. So we only have one y-intercept, and it is at +3. Now, to be on the y-axis, the number goes in the y spot. So that 3 goes here. The x-coordinate of all y-intercepts is always 0. Always, always 0. All right, 2 more to go. Minimums, maximums. What does it mean for something to be a minimum? It means it's the lowest it's going to go. Maximum is the highest it's going to go. Part of the reason I did increasing, decreasing before this is you have all these points marked. In between your increasing and decreasing is where your potential minimums and maximums will always fall. Because if you think about it, if your graph is increasing and then it changes to decreasing, it just made a top point. It could be the tallest point on your graph, so that's where you'd want to look. So if we look, the lowest point on our graph is right here, in between this decrease and increase. This is our minimum value. Our maximum happens up here at the top, in between our increase and decrease. So this is our max. Now when we list those answers, those are coordinates. So we've got to find the x and the y of those. So let's do the maximum first. Maximum's out here. So we go back 2. So that means the x is -2. And then we count up 1, 2, 3, 4, 5, 6. So that means the y has to be +6. That's the location of that point. Same thing for our minimum. Back 4, down 3 takes us to the spot that we've noted as the minimum. So back 4 is -4, down 3 is -3, and we've listed those 2 locations that are minimum, maximum. Same thing here. Part of the reason I listed our increasing, decreasing first, this is the lowest spot. Notice it's in between a decrease and an increase. So this is the minimum value on our graph. It's the lowest it goes. This is the maximum up here. And those are always going to fall between increases and decreases in some way. Then we list the points. So the maximum's up here. Out 3, up 2. So right and up, those are both positive. So that's 3, 3. Minimums down here, it's back 1. So that's -1. And down 1, 2, 3, 4, -4. I've covered up a little bit of the graph with all my drawings. And that would be our answers for that set. All right, last thing I want to talk about. Last thing I want to talk about here is end behavior. So end behavior, we've got this really funky notation for. And again, just like the last stuff, I think the notation is tougher than the concept, okay? So end behavior is referring to what happens at the ends of our graphs. So let's look at this first one. The ends of our graph just kind of tail off to the edge of where we see them and they just disappear, right? Does that mean that this graph stops right here? It doesn't. Anytime you see that, what you should realize is what we're trying to say is that graph should have an arrow. But any of your electronic graphing devices, they don't put arrows on stuff. But arrows are what end behavior describes. And what we're saying is this is the important part that changes. After this graph does the same type of stuff that it's doing here forever. And what I mean by that is if I ask you to describe this in two directions, which way it's going, this part of the graph is slowly going to the right. Where else is it going? As it goes to the right, where does it go? Does it go up or does it go down? It goes up. So as you got to think as we're tracing along this line, it's going to the right ever so slightly, and it's going up. So as I go to the right, the graph goes up. On this side, this graph, even though it's really hard to see, you can see it's slightly moving to the left, very slowly. So this one moves to the left. As it moves to the left, where else does it go? Does it go up or does it go down? Well, the arrow points down as well, so that means this thing goes down. That is exactly what this notation right here is asking us to tell it. It just is all math speak instead of up, down, left, right. So let's look at what this says. This says as x goes to negative infinity. So on the x-axis, which direction is negative infinity? The left or the right? It's the left. As we go this way, x's become more and more negative, eventually to infinity. So when we said left, what we're really saying is x goes to negative infinity. What it's asking me is it's asking me to tell it what the y does. So I'm going to shorten this box. Everything that's inside this blue dotted box is a given for end behavior. The only part that you need to fill in is this part right here about what y does. So we know that left, that this means left. How do we say down? Is that a negative infinity or a positive infinity? Well, as we go down on the y-axis, the numbers become negative, more and more negative. So we got to put negative infinity here because negative infinity is what down means. X goes to positive infinity. That's to the right. If we're on the x-axis and we're going to the right, all the numbers are positive and they get bigger and bigger. And it wants to know what this description is. That's what goes in here in this yellow box. Well, up on the y-axis, all the numbers become more and more positive. So as we go on forever, that turns into positive infinity. And do notice that this end behavior box is the same on each one. That part, even if you may have to write it because it's not there, won't ever change. The stuff that changes is the stuff here at the end, where we have to describe what the graph is doing. Let's do this one together. So this should have arrows on it. And we see that this graph is obviously moving to the left, but it's also moving down. This part moving to the right, but it's also moving down. So we know left is negative infinity on the x. What is down? Is down positive infinity or negative infinity? negative infinity. As we go right, that's x positive infinity. This means y. We want to know what the y is doing. The y is going down, and down on this is again going to be our negative infinities. We get a whole lot of positive infinity, negative infinities with real graphs here. There is one exception, which is what I have drawn right here, okay? So let's put the arrow points in here and look at this. This one right here is pretty straightforward. It goes to the right, and we see that the graph as it goes to the right is going down. But this is where the graph goes to the left. Is that one gonna go up or down to infinity? And this one's weird because I've got this green dotted line in here. This green dotted line stands for an asymptote. And an asymptote is, if you looked at our rational functions and stuff, it's an imaginary line in our graph, but it helps describe why our graph has certain shape. This asymptote is something this graph can't cross. It can't touch it, it can't cross it. It's like a big wall on the coordinate plane. So it tries to get really, really close to it, but it never quite gets there. The number where this asymptote is what our graph is trying to get to. It's what it's approaching. So we got to look at this, and we know that we've always looked at y values for this. So the y is approaching 1, 2 for that one that has an asymptote. And it gets, so this would be 2. So when we wrote our answers here, as we go to the left, the graph approaches 2. So we go to the right, that's down, that's negative infinity. The only graphs that you need to worry about asymptotes for are exponentials, logs, and rationals. And we will go deeper into both of those. But right now, I just want you to try to identify what it looks like, how it looks different than what we would see for a normal graph. So let's take a look at one of these exponential graphs, okay? I'm going to plug in an exponential graph and kind of give you a better look at this. So let's go 4 to the x. That's an exponential graph. And what I'm saying is the way that you can tell the difference between a graph that just kind of goes right into infinity is if you look at what we have here. As we move to right, this graph is still continuing to move over to the right a little bit as it goes up. But what does it look like this backside does? It almost looks like it becomes a straight line, right? And as you go farther and farther up, you can see that even more. This still continues to get some space and move to the right as you move up it. But this one, as you move back to the negative infinity, it almost becomes exactly one space, one spot, almost linear. That's how you visually tell the difference. And that what should tell you is that, hey, there's an asymptote there. And that asymptote, and Desmos is really nice about it, because once you do, you see how the y value is never changing in that point as I drag along it? That's because the asymptote of this graph is at 0. It approaches that y value of 0 and it never goes past it. But if you drag the other way, notice that both of those numbers are changing constantly as I'm dragging it up. That means it's going to the right and up like I thought. So you can look through Desmos to help you with some of that. So I think those are the two most difficult, well, the few most difficult features, okay? And that's pretty much all of them. So from here on out, we just want to work on our poster and everything.